Hello, welcome. Next video regarding metric space. Next part, metric space. Before going to start metric space, first we should know about absolute value function. Absolute value function, what are the properties of absolute value function? ज्याला आपण केवल मूल्य असं मराठीमध्ये म्हणत होतो. Absolute value function. Here these are the main four properties of that absolute value function. Absolute value of 0 is 0. Absolute value of a is greater than 0 if a is non-zero. If a is non-zero, then it is greater than 0. Mod a is mod minus a, means both values are same. Mod a plus b is less than or equal to mod a plus mod b. Here we consider R. A belongs to R, set of real numbers. And these are the properties of absolute value function. Notation: if xy belongs to R, then distance from x to y. Distance from x to y is denoted by rho. It is denoted by rho, where rho of xy is equal to mod x minus y, where xy belongs to R. Here we consider mod x minus y. What is this? Means x minus y is nothing but the difference. Moreover, it is the distance, because mod is always positive, distance is always positive. Therefore, rho of xy is the symbol for this mod x minus y. And now we are ready to define metric space. Definition: let M be a set, capital M be a set, a metric for M. That M may be whatever it may be. A metric for M. We apply any elements, or we take elements from M. Therefore, a metric for M is a function or row with a domain M by M. Means M by M. Here is M, and a range contained from 0 to infinity. A range contained in 0 to infinity means positive, you may say, such that these four properties, carefully we observe these four properties, absolute value properties. Similarly, here also properties of metric. Rho of x is equal to 0 means rho between that same point is 0. Distance and metric, these have similar meaning. Therefore, distance between x and x is 0. Similarly, here also we write rho of xx. Rho of xx mod x minus x, that is 0. Next, that is rho of xy is greater than 0, positive, because x is not equal to y and absolute value of any number is positive. Rho of xy is equal to rho of x. Distance from Tasgaon to Sangli, or from distance from Sangli to Tasgaon, same distance. Therefore, here also same metric, and hence rho of xy is equal to rho of yx. And this is the triangle inequality, you may say. Rho of xy is less than or equal to rho of xz plus rho of zy. Means suppose there is a distance, this is triangle, you may say, then x, y and z. Rho of xy is less than rho of xz plus rho of zy. And this is fourth characteristic. And if these four characteristics are satisfied by that capital M set, then M row, ordered pair M row. Here row is the metric for M, then ordered pair M row is called metric space. And of course, fourth property is called as a triangle inequality. There are mainly 5 examples on metric space. Today we are going to discuss only 2 examples. The function rho defined by rho of xy is equal to mod x minus y is a metric for R. This is the metric. How we can show it is a metric? R is the set of real numbers, and if it is a metric, then we call it as the absolute value matrix, because this is the distance matrix, absolute value matrix. This definition example is totally related to the absolute value matrix. Explanation: if these four conditions are satisfied by this definition, then we say that it is matrix. Okay? If these conditions are satisfied by this definition, then we call it as a matrix. Therefore, mod x minus y is the distance between x and y of this x. First property, rho of xx. We write mod x minus x, that is mod 0, that is 0. Therefore, first condition is satisfied. Second, rho of xy is equal to mod x minus y is greater than 0 is also satisfied because it is a positive. Third, rho of xy is mod x minus y. Mod x minus y can be written as mod y minus x. In absolute that sign, we can change the sequence x y y x, and that is rho of yx. Therefore, third property is also satisfied. First property, second property, third property, and fourth now. Rho of xz is mod x minus z. Write minus y plus y in place of this and separate it. By our inequality, we write this expression. And hence, four properties are satisfied by this distance, and hence it is a metric. This definition is about metric. Second example, define d from r by r to 0 to infinity. R by r, set of real number we write, and these are the two definitions are given for that function. D of xx is equal to 0 and d of xy is equal to 1. These two which are given obviously says that our first two properties are true. Why? Because 1 and 2 property of matrix space is satisfied because rho of xx means distance of xx is 0. Given. Okay? And second, rho of xy means d of xy is 1, and 1 is always greater than 0. Therefore, this is given. By given, we say that first and second property is true. Now, third property. We write rho of xy as a distance of xy, and it is nothing but distance of yx. Means here is 1, and this is also 1, and therefore rho of yx. Distance of xz is equal to distance of rho of xz is equal to distance of xz. Here 1 is always less than or equal to 1 plus 1, isn't it? Therefore 1 is less than or equal to 2, and this is the theorem. Rho of xz is less than or equal to rho of xy plus rho of yz. If x is not equal to y, we write 1. Therefore 1 is less than or equal to 1 plus 1. It is true. And hence third and fourth are also satisfied. Hence all four characteristics, all four properties are satisfied by this definition. Hence D is metric for R. Now this is also one different metric, because here only we write 0 and 1. Distance of xx is 0 and distance of xy is 1. Therefore this is the discrete metric. Hence in note we write this metric is called a discrete metric, and it is denoted by RD or RD. R is set of real number and D is distance. This is one example. Discrete metric space, absolute value metric and discrete metric. These are the two examples. Let us see next in next video other examples relating to metric space. Okay, thank you.